For our 390 project, myself, Russell, and Dom have made the game Kitchen Chaos, where you, the player, take place inside a messy college apartment, where you have to navigate the various objects and cockroaches to trap the boss cockroach, the mother cockroach, in a Tupperware container to exterminate the bugs and end the game. So just to start off with a quick playtest, the player will move around the map with various objects in their way, and so which we will get into later for the behavior tree. But for the cockroach, there are three main behaviors where it has a random patrol point. That is its default. It will randomly patrol various points in the map. The second thing is that when you throw a piece of bread, it will lure the cockroach over to where the bread is, and it will sit there and eat the bread for a few seconds. And then the main behavior is that when the cockroach sees the player, it runs away to a target point, but the cockroach will keep running as long as the player sees it as a fear. So the cockroach will keep running away from me as long as I can see the cockroach until it gets to a cover point where it can hide. So if I turn away, the cockroach will return to a random patrol point radius as it just moves around the game. Now, to beat the level, your goal is to trap it in the Tupperware container. You can use this with various things such as bait. For bait, we are going to be throwing a piece of bread over here to bait the cockroach over while avoiding the small cockroaches which do damage to you. Now the cockroach boss will make its way over there to eat the bread, and it will sit there for 6 seconds while it's eating the bread to give player time to get to the trap button. The trap button being located on top of the counter. Now for playtesting, we have made this a little bit easier as the cockroach won't stay there as long and be more of a random control, but for testing purposes, we have decreased the difficulty of this to allow for testing of the behavior and how the game operates. So normally the player won't be able to get up here as fast and the cockroach still be there, but for testing we are using that. So as you can see, there is a button here to trap the cockroach. Now we will look over to see where the cockroach is, throw a piece of bread to bait it over there, and drop the Tupperware to trap, and the kitchen has been exterminated. So that is the basic playtest of our game. Play, quit menu, equipped. Now showing off the logic for our cockroach boss. So to start off, in the player blueprint, we are using a line trace by channel. So as I discussed earlier, when the cockroach sees the player initially, it runs away, but it will keep running in between target points until it breaks line of sight of the player. So even if the cockroach is turned and run away from the player, if the player can see the cockroach, it will stay in a flee state. So how that works is that we are using get actor location for the boss and the player, and using normalize and dot variables to determine that point. And this operates off a tick event, and what creates that line of sight is a line trace by channel, which draws a line between the boss and the player model, and if that gets broken through different cover and such, it will false the boolean. But as long as the player sees the cockroach, it will continue to be in that flee state, which will set our blackboard components. Now just to really cover the ball as well, or the bread. The bread that is thrown is a simple event hit where it sets a hit location, makes a noise, and then using our boss controller with AI perception, it has sight and hearing, so we can determine where to go, and with priority being sight over the hearing sense. And this is our logic for seeing the player as well as hearing any ball impact or stimulus location. This was sourced from the Unreal Behavior Tree guide that we did for our first project in 390. Now to cover the main part of our project, which is the one of two components, is a behavior tree for a BP boss. So we have our various blackboard keys here, but the main thing is the behavior tree. So how this works, as I discussed earlier, the default logic for the boss is a random patrol point, where it will find a random patrol point in a radius that is suitable around the boss, and it will set one of those patrol points and go to it. So this being our lowest priority, this is on the right side of the blackboard, determined by the higher execution index numbers. Then for our chase ball or chase the bread that is thrown, we are using decorators to determine that did the ball or bread have actual impact. If yes, then it will execute the various BTT tasks, which determine where the cockroach has to run to for the location. We also have a decorator, so when the cockroach sees the player, it aborts all of this below to ensure that that takes priority. Now, for our main logic, as I had talked about earlier, is that when the cockroach sees the player, it enters a flee state, and it will continue in that flee state until it finds cover away from the player's line of sight. So what starts that initially is this: does AI have line of sight of the player? When this happens, when the AI sees the player, it triggers our various BTTs to find cover points and set cover. So for finding cover points, we are using target points placed around the map, where when event receive execute AI goes through, finds all of the different target points we have placed around the map, and chooses a random one in range to go and hide behind. So this ensures a random behavior that the cockroach always has a different target point to go to and is never predictable AI. Going back to the behavior tree, this is what allows the cockroach to stay in a flee state as long as the player sees it. If the boss is already escaping, which is set by the initial sequence, it will continue to find cover points, move to cover points, as long as the player can see the cockroach. As soon as the player breaks line of sight, it turns this decorator off and returns to its default logic of patrolling around the map. And then, so just explain that in the overhead view, the cockroach will move around this map in various points. But as you can see, we have target points placed around the map that the AI will run to when it's in its flee state. When it's not in its flee state, it just is idle and random patrols. And the goal is to use lures to lure it over to this location to drop the Tupperware container and drop. As you saw in the playtest, when the Tupperware drops, the game ends. You return to the top of the map with a victory screen, and then the main menu displays. And that is our main behavior for the AI boss, which is one of two. The other behavior that we're using is steering behaviors, which will be covered later.
Okay, I'm Dominic. I will be explaining the steering behavior for the enemy AI. So first, every 10 seconds, a cockroach will crawl up from the ground and will start chasing the player. The most important line is the blue line, which is a combination of different vectors that tells the cockroach where it should be walking. So basically, instead of traditional pathfinding, we get a sample of the AI's direction every tick, and we score them based on interest and danger, and then pick the best one. You can see it navigates around obstacles in real time. The green line is interest, the red line is danger, and the blue line is the chosen direction. So moving into the blueprints, here is the enemy BP. Basically, this is just the crawling up behavior. What we're doing is I set a hard value for the floor where it's setting to, because originally I was using the character's location, but I was getting enemies spawning in the air. And then we teleport them 150 units underground. We set the mode to flying so that the gravity doesn't interfere. And then we use a timeline and the Z position lerps, but from below the ground to above the ground, and then we return the movement behavior. And being shown now is the enemy killing code. Okay, up next is the blueprint tree. Not a lot going on in here, just a route, and then it's looping through a sequence where we update the player target, we compute the contextual steering, and then we move in that desired direction. Okay, moving on to the update player. This task is tiny. All it is it grabs the player pawn every cycle and writes it to the blackboard so that the enemy always knows where the character is. Alright, now time for the bulk of the system. It's the context sensitive steering. We sample 12 different direction slots spread over 360 degrees around the AI. For each slot, we calculate two different scores. It's interest, which is a dot product measuring how much that direction points towards the player, and danger, which fires a sphere trace and scores a high if it's nearby geometry. The final score is interest minus danger weighted together. We also add a small bias towards the previous frame's best direction in case of you're standing in the middle of an object and the AI cannot decide which way to go. After we loop through the highest score direction, smooth it with vinterp2, and write it to the blackboard and finish the execute. And finally is our move in direction task, where our AI finally moves in the desired direction. But it does it in a loop, so it always has a new direction it's heading towards. Last but not least is killing. It's kind of like Mario, where you drop an enemy and it gives you a little bit of upward momentum, and if it hits you by the side, you die, and then eventually you will respawn. Last but not least is the logic we added to our player character. Just simple things like damage and updating the health bar and letting know when our characters are dead so we can respawn our character. We didn't destroy the actor because it was causing problems. But other than that, that's the project. We have been arting it up and adding sound effects, as I'm a sound designer, for our portfolio, but that stuff unfortunately wasn't done for this presentation. But I do have the 2 themes I composed for this. You've been hearing it in the background, and there's the main menu theme, which we'll play in a second. Hope you enjoyed.